All right, problem number 3, we changed topics up a little bit. We're going to be dealing with conservation of momentum. And again, we kind of know this because we've got two objects, and it looks like we're dealing with one, if not two speeds. So let's go ahead, let's first sketch out what's going on. So we have this sphere racing through the air, and then we have some dude right here standing very huffily and defensively, waiting to get struck in the chest. And then this is the before, and then afterwards what happens is that the ball bounces backwards, and apparently the guy, I don't know why I'm making this a male getting hit in the chest and moving, but sure, why not? So he ends up going that way. So I don't know why he's wearing high quality rollerblades. It's not 1997 anymore. I need to change my cultural references. So let's go ahead and actually use the conservation of momentum to solve this. And for those of you that are trying to remember what the Sam Hill conservation of momentum is, did I neglect to put the formulas on there? No, I did put them there. This dude right here. That's conservation of momentum. You wily thing. Okay, so let's get back to the problem. So we have here m1v1 plus m2v2 equals m1v1 plus m2v2. And these are initial and final values. So initial, final, and final. Very exciting. Now, here's what we're saying. We've got a 5 kilogram ball moving at 8 meters per second, and it hits an 85 kilogram dude who's not moving. Then what ends up happening is that this 5 kilogram ball bounces back. That word bounces back means you need a negative here. So negative 2 meters per second. And then we have no idea what's going to happen to the guy's final speed, so I'll just call it V2. So what ends up happening is we end up getting here 40 equals negative 10 plus 85 V2. So 50 equals 85 V2. And when you finally solve for what V2 is, that is going to end up being 0.6 meters per second. Now, the impulse delivered to the ball, if you actually look up the definition of impulse, that's force times time. And this is not going to be helpful to us. So is this the right formula? It is, but it's not useful here. The other formula for impulse is to get the change in momentum. So let's actually calculate it that way. That's going to be 5 times v final, which is negative 2, minus 5 times 8. So we're going to end up getting here negative 50, and the units are Newton seconds of impulse. Now, if we want to get the force, now we use this formula down here. So force times time equals negative 50 Newton seconds. So we have force times 0.2 equals negative 50. And so we're going to end up getting a force of negative 250 newtons acting on the ball. And then for part D, what is the force applied to the man's chest? It is actually also 250 newtons, but positive, and that's because of Newton's third law. That is, the force on the guy due to the ball equals negative of the force on the ball due to the guy. So that's it for the momentum problem, and we will take a look at problem number 4 in our next video.